Hello everyone, hope you all are doing well. So in this video we'll be discussing the second problem of Leetcode Weekly Contest 313. It's a media level problem. So the problem name is maximum sum of an hourglass. So you are given m cross n integer matrix, and we define an hourglass as part of the matrix with the following form. So you can see here A B C D E F G. This is known as hourglass. This shape is known as the hourglass. We need to return the maximum sum of the elements of an hourglass. Note that an hourglass cannot be rotated and must be entirely contained within the matrix. We have a couple of examples. Let's directly jump into the explanation. So I will pick up the second example. That's an easier one, not easier one, but basically it's a small matrix. So yeah, this is the matrix. This is the matrix. We have some numbers like obviously 1 2 3 4 5 6 7 8 9. Suppose these are the numbers. So the problem says that this is the form of an hourglass. The three elements and one element in the middle, right? This is so. Just see how many hourglasses can you form, right? So if you pick this element, firstly you can, like, let's consider that we are picking up the middle element, right? We are picking up this middle element, and somehow then we go to the row above it and row below it, right? So if I pick this as the middle element, then obviously this is the topmost row. That means the first row, the elements in the first row cannot be considered in the hourglass if I take these elements placed at this position, right? Because you need a row above that as well. So that means these elements cannot form the middle element of the hourglass. Similarly, these elements cannot form the middle element of the hourglass, right? Now let's consider the leftmost column. If I take this, then obviously I have a top row, I have a bottom row, but on the top row as well I need one element just above it and one element before it, right? Similarly, if I take this as middle element, so I need one a row below it and also an element here, right? Because this needs to be shape of an hourglass, right? This is the shape of an hourglass, right? So that means first row, first row, last row, first column and last column, the elements in these in these rows and columns cannot form the middle element of the hourglass, right? So in this case the only element left is 5. So you take this as the middle element, and then you calculate the sum of these three, and return your answer, right? Easy stuff. Why I took this example is because it was a small matrix. Now let's consider a larger matrix. Suppose this is the matrix. Let me consider a 4 cross 4 matrix. So as I told you, we cannot take these elements as middle elements, right? These elements. So how many elements are left to be taken as middle element? I can take this one, let's call it 1. So this will form an hourglass, this and this. If I take this, then this row and this will form an hourglass. Similarly, if this is 3, this is 4. So for this 3, let me just change the color so that we can differentiate between them. So for this 3, these will be forming an hourglass, and for this 4, let me just change the color once more. Let's take green. Let's take green. So now for this 4, these will be forming an hourglass, right? Basic stuff. Now comes the question. We are clear that what do we need to do, what are the elements that we need to consider. Now comes the question, how you calculate the sum of these three elements, right? For an hourglass, if you consider this as the middle element, how will you calculate the sum of these elements? Obviously, one thing can be you consider it as middle element and just traverse every time, and we will be good to go, right? Traverse these three elements, and we'll be good to go. We can find this sum. We can do this for all the middle elements. So that will also work. However, a better approach can be, I can take a prefix array, right? So I can build a prefix array, something like this. This is my prefix array. So for every row I'll be calculating the prefix sum. So in this case, what I can do, everyone knows what's a prefix sum, right? So basic stuff that uh, I'll be starting my indexing from 1 just for simplicity, so that I do not introduce too much of if else cases, that okay, if my index is greater than 0 and all. So you start your indexing by 1. So this here, the value will be 0. This will contain the value till here plus the current element. Similarly, this index will contain the sum of these all plus the value present at this index, that means I comma j, and obviously the sum of these are stored here. So everything will be happening in O1 time, so you will be traversing, and this will be big O of n. So for building it, the total time complexity will be big O of n cross m. So once you build it, then what you do, you take this, you do it for all the rows, then you take this as middle element. When you take this, you want to find the sum of these 3 elements, right? What do? You know the prefix sum till here, you know the prefix sum till here. What do you do? Suppose this value is x, this value is y, you do x minus y, you get the value of these 3 elements, right? Similarly, you do for these 3 elements. So these operations will be done in O1, and obviously you'll be having a better time complexity in that case. So these operations are O1, you traverse, and overall time complexity will be O of n cross m, and finally you return the max answer that you get among these values, right? Let me just jump into the code, nothing fancy. You can see here what we have done. I've calculated n and m. On line number 7, I've built a prefix sum. Again, number of rows is n and number of columns is m plus 1. Why I haven't taken indexing from 1 in case of rows? Because I am skipping the first row and the last row, right? So my indexing will itself will start from index number 1, so it won't be too much complex to handle, right? So what I have done, I have calculated the prefix sum. So prefix sum of I comma j plus 1 equals to prefix sum of I plus I comma j and grade of I comma j. You calculate it, and then finally what you are doing, I am running a loop. You see that I am counting the rows from I to n minus 2. I is less than n minus 1, so that goes till n minus 2, and similarly I do that for columns. The current sum will be again grid of I comma j, and I have calculated the diff. So as told you, the row above will be I minus 1 j plus 2 minus prefix sum of I minus 1 j minus 1. Just handling the indices, and similarly you do for the row just below this, below this middle element, and you do answer equals to mat.answer. You find whether the current sum plus diff is greater or answer is greater, and then you update your variable. Finally you return the answer, right? So yeah, this is the solution, and the overall time complexity will be big O of n cross m, because you'll be traversing the grid multiple times, once while building the prefix sum and then while doing this stuff, right? So yeah, I hope you learned something new from this video. Do support it by giving up thumbs up. Do subscribe to the channel. In case you have any queries, do mention that into the comments. I'll revert on each one of them. Thank you. Take care. Bye bye.